Hello and welcome to paper solution of GTU Basic Engineering Drawing exam paper of January 2012. Now we will solve the examination paper accordingly. Please look at the question 1A. The question 1A says that we need to divide a 80 mm long line into 7 equal parts. Now we will see method to divide a line into equal parts. This method can be used when we want to divide an unequal line into equal number of parts. Over here we can say that if we want to divide 80 mm line into 7 equal parts, then the divisions would be unequal. So we will use this method. Let's say we have line AB 80 mm long. We have this 80 mm long line and we need to divide this line into 7 equal parts. We have AB. Now what we are going to do, we are going to draw line of 70 mm at any angle. We have drawn a line of 70 mm at any angle. You can choose any angle to draw this line. Now if we want to divide this line into 7 equal parts, then it will be very convenient. We'll divide 70 mm into 7 equal parts. That means that we are going to divide this line for 10 mm each for the division. 1, 2, 3, 4, 5, 6 and 7. We have got 7 divisions on the line AC. Now join line BC. We have joined line BC. Now give numbering to the divisions we have got. 1, 2, 3, 4, 5, 6 and 7. Now draw parallel line to BC from the each division. You can draw this parallel line with use of set square or with use of roller scale. That's it. We have got 7 equal parts of 80 mm long line. I have given the nomenclature to the achieved point. 1, 2, 3, 4, 5, 6 and 7. All parts are equal. You can use this method to draw this equal part to unknown dimensions. I'll repeat again. First of all, draw line AB of 80 mm, then draw line of 70 mm at any angle. Give name AB and AC. Join BC. Then you need to divide this AC line into 7 equal parts. This line is of 70 mm, so each division would be 10 mm. Now join this line parallel to BC from 6 to 6 dash, 5 to 5 dash, 4 to 4 dash, 3 to 3 dash, and accordingly, and you will get your desired divisions. You can use this method to divide n number of parts. We will move forward to another question. This question says that with help of the neat sketch, differentiate between align method and unidirectional method. These methods are of the dimensioning system. There is a clear difference between these methods. I will show you how this method works. Further, you should also know that dimensioning is most important parameter for any drawing. If you do wrong dimensioning, then your marks can be deducted. If you don't do any dimensioning, how an examiner can know that you have drawn this kind of dimension, you have got that kind of dimensions. Now we will further proceed. I am drawing a reference sketch from which we will clearly mention the difference between two systems. First of all, I will draw two reference blocks, and then we will see clear difference between them. We have got two reference blocks. We have got two reference blocks. Now we will see what is the difference between two dimensional systems. First of all, I am going to use align method. Align method. Now let's first see how dimensioning can be done. These two lines which I am pointing indicates the distance which we are measuring. So these lines are called extension line. Now we will putting a dimension line. The line which I am pointing is called dimension line. On both ends of the dimension line, field arrow must be indicated. Now in the align method, the dimension should be written above the dimension line and middle of the dimension line. We have got this dimension of 80 mm, so I am writing 80 over here like this. Above the dimension line and in the middle of the dimension line. This is about horizontal dimension. Now we will see how we can give vertical dimension. Same extension line, a dimension line, filled arrow on the both side. Now we have got this distance of 40 mm. So how we are going to write this 40 mm? We are going to write this 40 parallel to the dimension line, again above dimension line and in the middle of the dimension line, like this. Same way on another side. I have got extension line, I have drawn the dimension line. Filled arrow on the both side. I have got the dimension of 60 mm. So I am going to write this 60 above dimension line, in middle of dimension line and parallel to this vertical dimension. Upper dimension we have got over here. First of all we will draw extension line, then I have drawn this dimension line, filled arrow on the both the side. Again the dimension is above the dimension line and in middle of the dimension, also parallel to the horizontal line. We have got this dimension of 60 mm. So I am going to write 60. Now the last dimension remaining over here is the dimension of this circle. Okay, how many of you know that how we can denote the diameter? We should denote diameter with use of phi. Phi should be denoted like this. Phi is equal to diameter. So if you want to draw a circle of if you have draw diameter of circle 10, so you should mention diameter 10 instead of writing dia 10. That's a wrong method. This is right method. Now how we can give the dimension to a circle, we'll see. To give dimension of the circle, draw an arrow in the middle of the circle like this. take out another arrow like this, extend it, and give the dimension above the dimension line, that is diameter 10. This method is known as align method. Now we will see unidirectional method. What is the difference between align method and unidirectional method? We will see. This method also have extension line, dimension line, both. We'll draw extension line, then a dimension line. The only difference is that the dimension line would be break from the middle. On the both side, field arrow should be there, and you should mention the dimension in the break space, that is in the middle of the dimension line. Don't forget to put field arrow on both the ends. This is about horizontal dimension. Now let's see about vertical dimension. Extension line,